What's up, Math 8? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at our last lesson in Chapter 4. It's 4.9 using similar triangles, and then we'll get ready to take a test here soon. Our main objective today is to use similar triangles to solve problems. Let's go and get into it. When two angles in one triangle are congruent to the two angles in another triangle, the third angles will also be congruent, and the two triangles are now considered similar. So let me print out a little visual for you. We'll just pretend that both of these are isosceles triangles, and let's say they are similar based on their side lengths, but we also want to make sure they're similar based on their angles. Let's say that we have, 70 degrees here and 70 degrees here. Because these two triangles are similar, that automatically means these two angles should also be 70 degrees. And then the third angle will also match. So we know from our previous lesson that all angles in a triangle are 180. So if we do 70 plus 70, we get 140. And then if we take 140 and subtract it from 180, we get 40 degrees. So that means this top number is 40 degrees, which means this third angle from the previous triangle we can also prove is 40 degrees. So when two angles in one triangle are congruent to two angles in another triangle, the third angles will also be congruent, and it'll say that those triangles are similar. Remember, similar shapes have same angles, proportional sides, and that's what we're showing here. What we're going to do here is we're going to try to figure out what is going on with the two triangles and if they are similar, and then explain it. The first example, we have 75, 50, and x, and the second example, we also have 75, 50, and y. The first thing we want to do is maybe figure out what is x equal to and what is y equal to. But if you notice, 75 matches this 75, 50 matches this 50, so we should be able to determine that x and y are equal, because if we take 75 and add 50, we're going to get 125, I believe. We're going to double check that with the calculator because sometimes people's brains don't work normally. Yes. Then if we subtract 125 from 180, we're going to get 55. So that means x is equal to 55 and y is equal to 55. So we can say yes because all angles are congruent. Let me fix this word angles because that looks terrible. Angles. There we go. Let's try letter B. Letter B also has similar things going on, except now some things have been switched around. So letter B, we have 54 and 63, and then on this side we have 63, 63. One thing to keep in mind is these probably are similar because we're seeing the common theme of 63s. One thing we can do is we can just prove this using that triangle interior angles theorem. If we wanted to, we can add 54 and 63. We're going to get 117. And then we would just take 180 and subtract 117 to get our missing angle. And we're going to get 63. So this angle right here is also 63, which means over here, if the two 63s match, then this third angle should also match, which means this should be 54. So we're going to say yes because all angles are congruent. Okay. Let's see if you can try this one on your own. Can you go ahead and pause the video here, try this one on your own, and then see if you can get the right answer by yourself. All right, one thing you can try is go ahead and decide what is 90 plus 42 in the first triangle. I'm going to get 132. And as long as my difference between 132 and 80 is 138, then I can prove that they are similar. 180 minus 132 is 48. And I'm just going to double check my subtraction one more time with my calculator. I'm getting 48 here, which means this angle measurement is 48. Now, notice how it doesn't match with the 38 over here. So let's just see what happens as I solve for the missing piece over here. This one would be 90 plus 38. And I'm going to get 90 plus 38 is 128. So already you can see that these two numbers are different, the 128 and the 32. 180 minus 128 is 52. So in this case, we have to say no because angles aren't congruent. Okay, so sometimes it looks like they're congruent, but we want to double check and just make sure we're solving for those missing angles to prove it. Here are two further examples. Let's go ahead and try these. Take a moment to try them by yourself. So we're going to pause the video here, try it on your own, and when you're ready to check it, click play. All right, so number one, what I did first is I added 28 plus 80, and I got 108. And then I'm taking 108 and minusing that from 180. I'm going to get 72. So 72 degrees is my missing piece. If you notice, I have 28 here, but then I have a 71, which means this y is not going to be the same thing as 80. So we're going to say no for number one because angles aren't equal. If you wanted to double check this second one, I just did 28 plus 71 really quickly. You get 99, and then 180 minus 99 is 81, and notice that they don't all match. Okay? Onward to number two, you can start by doing 66 plus 90. You're going to get 156, and then you take your 180 and subtract 156. You're going to get 24, which, look, matches the 24 here. Just for kicks and giggles, you can double check your work. 24 plus 90 in the other one is 114. And 114 take away from 180 is equal to 66. So y is equal to 66 in this one. So we can say yes, they're similar because angles match, or because they are equal. Okay? Let's try this one. This one says solve for x, and x is right here. And it says EDC is equal to UVW. And the way we're going to be able to solve for x is if we first figure out what is DE matching with. Okay? DE, which is these two first letters, is going to match with the first two letters in this triangle. So UV. So that means I have 39 is equal to 3x plus 19. Again, I found that by just doing the stack method that we learned back in the very beginning of chapter 4, EDC, U, V, W. I was concerned with letters E and D because ED has the 3x plus 19 and my main goal is to solve for x. So ED is right on top of UV and UV has that 39. Let's go ahead and start solving. I'm going to first start by moving my 19 over. So I'm going to do 39 minus 19. I'm going to get 20. Is equal to 3x. I'm going to get probably a repeating decimal or a mixed number here because when I divide both sides by 3, I'm going to get like 6.3 repeating, 20 divided by 3, or 6.6 repeating. So we can just say this is 6 and 2/3 is equal to x. Or if you said 6.6 with a little repeating sign, that would be fine as well. Here's another one we can try. We have STU is similar to SED, and what I need to do now is look to see how my angles are changing. I just realized that I did this question wrong because this symbol right here means similar. So if they were congruent, that would have worked, but because they're similar, I got to start all over. So look at that. Your teacher just made a mistake. I'm so sorry that I wasted your time. Let's try this one more time. Similar means we can set up a proportion to maybe solve for the missing variable. So 3x plus 19 does match with 39. So 44 has to match with 33. So what we're going to do here is we're going to cross multiply 39 times 44. 39 times 44 is going to give us 1,716. That means 1,716 needs to be equal to me multiplying these things, okay? Now, when you multiply these things, this means 33 times 3x plus 19 is equal to 1,716, okay? It means I'm going to do some distribution here. 33 times 3 is 99. And then 33 times 19 is 627. You should be using a calculator to help you. Next, I'm going to subtract 627 from my 1,716. I get 1,089 is equal to 99x. Final step, divide by 99. Dividing by 99 gives us 11. So x is equal to 11. Okay. One thing you could have seen is 33 relates to 44 by, this was made by 3 times 11, and this is made by 4 times 11. So this one can be made by 3 times 13. So 4 times 13 could also give you your answer, which is 52. And then 52 minus 19 is 33. And then you have 3x is equal to 33 divided by 3. You still get 11 as your answer. Okay? So now that we know that, let's try this. STU is similar to SED. So SE matches with ST, 77. So we're going to build a proportion. 3x over minus 9 over 77 is equal to, I got this one, DS is equal to US, 21 over 77. Okay. What I need to think about here is how they maybe grew and how I can solve for them. One thing I might want to do is start by cross multiplying. So 77 times 21 is 1,617. And then 77 times 3x minus 9. 77 times 3 is 231x. And 77 times 9 is 693. So minus 693. Okay, so now I have this. 231x minus 693 should be equal to 1,617. I'm going to add 693 to both sides first. I'm going to get 231x is equal to 693 plus 1617 is 2,310. When you divide by 231, you're going to get x is equal to 10. Okay. Indirect measurement is one more thing that we'll talk about. That is using similar figures to find an unknown measure when it's difficult to find directly. So this is the last little blank we'll fill in our notes. Now let's get ready to try an example. You plan to cross a river and want to know how far it is to the other side. So you take measurements on your side of the river and make the drawing shown. Explain why ABC and DEC are similar, and then what's the distance x across the river. We know that ABC and DEC are similar because they have matching angles, and we can also set up a proportion to help us. So let's say that we have 60 over 50 is equal to, notice how I use this mark, AB matches DE. So I need to do x over 40. I'm going to cross multiply first. 60 times 40 is 2,400. And then I'm going to take that 2,400 and divide it by 50. Okay, 2,400 divided by 50 will give us 48. So x is equal to 48 feet. Okay. That'll conclude our notes for today. Thanks for hanging in there, especially with those two similar figures right before that. You just had more complicated proportions to look at, but hopefully that helped clear